Good afternoon, one and all present here. Myself, Dr. P. Janagaratnam, Department of Mechanical Engineering, SNS College of Technology. In my previous video series, I already discussed about the different types of machines, mechanisms, and what are the kinematic diagrams, how we are constructing these diagrams, and what are the inversions of mechanism, and all discussed. Today, I am going to discuss about the different kinematic terminologies, links, pairs, and chains. So generally, kinematic terminology means which considering the mechanisms. Mechanism means we have to combine all these things like links, pairs, and chains. We have to make the individual mechanisms. So what is meant by kinematic link? It is a rigid part transmitting forces and moves relative to the another components. Negligible deformations under the load. This is the links. This is one of the rigid part of particular machines or mechanisms which moves relative to the another components, which means another link and deformation, negligible deformations under the loading condition. This is the kinematic link. So this is the types of links we have to use in our kinematics, like rigid links, flexible links, and fluid links. So rigid link means unalterable form and precise motion and essential for accuracy. Flexible means transmit motions with some give and observing the shock and adapting shape. And fluid link means motions through pressure, power, and without direct mechanical contacts. So this is the defining of kinematic pairs, like different types of kinematic pairs like revolute, turning pair, sliding pair, and rolling pair. So the connections of points where links meet to and interact, that is called known as the kinematic pairs. And these are all the different types of kinematic pairs based on their applications and specifications. We have to select any kind of these pairs, and other screw pairs it produce the helical motion. Example is nut and bolt, and spherical is relative rotations about the central points like balls and jacket, and rolling, which is example for the wheel and mechanisms, and prismatic sliding means piston and cylinder. Here we are producing the sliding motion, and turning means rotation around an axis like hinge. This is the some of the kinematic pairs and classifications of kinematic pairs by contact, which may be called known as lower pair and higher pair. Lower pair means involves the surface contact between the link, higher force transmissions, less wear. And high pair means it involves the points and line contact alone, and more complex motion and higher stress. Most probably we can choose the lower pair because the surface contact is very much essential for our developing the mechanisms as well as the. So what is meant by next? First, we have to discuss about the links and types of links and pairs. Next, we have to discuss about the kinematic chains. A sequence of interconnected links and pairs forming a system that is called known as kinematic chains. And each link connects at least two pairs and enables constrained relative motions. There are two types of kinematic chains like open chain and closed chain. As a free unattached end link and common in robotics, closed chains form a complete loop, provides inherent stability and constraint. And from kinematic chains to mechanisms, fix one link kinematic chains and you are create the functional mechanisms like potential for motion, and establish a frame for reference. Based on their reference we have to make ability things, and mechanisms transforms input into the predictable output motions. We are giving the small amount of force which can be used to transfer or converting into the another type or another form of energy. So example, a slider crank in an engine converts the rotary motion into linear motions, because in our slider crank mechanisms we are giving the crank angle rotary motions, and the piston moves through the reverse and forward directions in a sliding pair. So that is which convert the rotary motion into motions. So this is the types of chains like binary links and tertiary links. Multi-link connections like tertiary links introduce complexity, which the complexity increases we have to go for a this kind of ternary links. And this is the real world examples like revolute pairs and other slider crank mechanism, 4-bar linkage like locomotive engine wheels. And these are all the some of the real world examples which will be used in our kinematic chains, links, and mechanisms. And this is the why kinematic terminologies matter, means foundational understanding essential for mechanical engineering like robotics and machine design. and it enables the precise design and analysis we using the analytics tools and optimize of the machine motion, and mastery unlocks innovation followed from the automation and aerospace. These are all the some terminologies why we have to choose it. And this is the general summarization of today's class, like kinematic link pairs, chains and mechanisms, and in-depth types of these links, pairs and chains. And this is the two assessment questions, and some of the reference we have to follow to take this kind of PPT from this kind of reference, and some of the NPTEL tutorial materials also can refer. Thank you. In our next video series, I have to discuss about the one more interesting topics which is related to the mechanical as well as the machines. Thank you.